So in a moment, you are going to work with your group, and you're going to make a big poster paper, and it's going to have two sides for the two claims that we're going to make. We're going to have a claim, a support, and a question. The claim, I do want you to try to write as a conditional because it's a very mathematical thing to do. I want an if-then statement for that. It also forces some precision of language, which is important and useful. Okay? For the support, I want examples and explanations. You'll give like relevant examples that demonstrate your point, and you will also explain why you think this is true. And then what about that last one? What fits for Q for questions? Have we talked about like very mathematician-y questions? What are some of those?
To what extent does this not, or to this?
Yeah. To what extent does this work? Will it always work? Are there exceptions? Can I come up with a weird case where it doesn't? I think claim support question is a hugely useful routine in mathematics. I think it's the baseline of mathematics, that it's the chord structure that happens and we improvise above it. So I think that stating a claim and then supporting it mathematically and then that leading us to further questions is what mathematicians do. It's what research scientists do. It's so useful.
If f of x is any function, then f of negative x is a reflection on the graph's y-axis, and negative f of x is a reflection on the graph's x-axis.
Yeah. Hold on.
Hold on, what are you noticing? What do you expect to happen versus what is actually happening?
Oh, okay. It's reflecting off the y-axis, but since y is, or the y-intercept is 0, or
You're so on the right track, but I think that your teammates might be able to help you with your precision of language on this. There's one of the big ideas. What's the other big idea? Well, what's happening here? I love the conditional. It's so clean, right? You guys are a very visual class. You guys are all about the graph, and I have to like pull the words out of you. So I'm pulling the words out of you. We want examples. You guys are drawing great pictures. And explanations. Oh, good math language there. Yes.
There's not an exact reflection, there's also a shift.
How is it not an exact reflection?
Because they don't...
So like if the starting point, like say 2,
Actually,
1,
no,
it doesn't
you're right.
flip directly
They're
from there.
exact.
I think that's what Lorena
But
was thinking.
they
but that
don't
doesn't-
flip on
yeah.
the vertex, but we don't have
Oh,
vertex,
okay.
and it's a point.
You brought up a good point. So that's also very mathematician-y, right? Like you count this example, you see this thing happen, and then you say, well, was that just like this particular case? Or will it always be that way? Or can I come up with exceptions to that? Or are there ways to make it flip on the vertex? Those are all questions. Okay, what did you learn about how each function is different and how they work differently?
So the way that they, for example, here the parabola is going to be represented is going to be different along the x-axis.
You guys chose what as examples? Which shapes?
Parabolas.
So possible questions are like,
Does this change for different shapes? But
Right.
doesn't because
Does it change, for example, for like a line?
the support you've given has been pretty focused on parabolas, so a legitimate area for further research, right? Because that's kind of how claim support question drives us. So figure out how to frame that, and I want these on the board.
Okay.
As a team, you're gonna leave a sticky that says something that you think is good about this, something they did well in this claim support question process. And then you will leave another sticky that either asks a follow-up question or gives a suggestion.
I think for math language, it's good to be very specific.
Definitely.
I like the graphs, but I think this shouldn't be here. I think this one only applies to here, so why is this one here?
I did that pretty well. Question: to what extent does the reflection depend on the vertex?
Right there.
So if you were to do this again, how would you do it?
I think all of our words were pretty solid. What I got to our graphs?
Our graphs.
All right, folks, thank you so much for your thinking today. So something that I noticed is they were very visual in their representations. Like they did pretty well with the graph, but it felt like they were just saying exactly what happened to that particular shape rather than relating it to the big idea of what reflections do and why. And so that's something that we need to draw out more deeply because I want them to understand not just the how, but the why, because the why hangs on longer.